Hello everybody, welcome back. So today I've got a nice little trigonometry problem for you. If sine of theta plus sine squared of theta is equal to 1, we want to find cosine to the 12th of theta plus 3 cosine to the 10th of theta plus 3 cosine to the 8th of theta plus cosine to the 6th of theta minus 1. So in order to solve this, we're going to need some tools. So we're going to need the classic Pythagorean identity, a bit of algebra, and maybe a bit more algebra. Okay, so be on the lookout for these as we solve. And I think with that said, let's go for it. So let's assume that sine of theta plus sine squared of theta is equal to 1. And under that assumption, we'll carefully find what this is equal to. So yeah, assume that sine of theta plus sine squared of theta is equal to 1. And let's start to investigate this. So cosine to the 12th of theta plus 3 cosine to the 10th of theta plus 3 cosine to the 8th of theta plus cosine to the 6th of theta minus 1, we can rewrite that. I'm noticing that if you look at the first 4 terms, we can factor out a cosine to the 6th. Let's see if that leads any place fruitful. So yeah, factoring out a cosine to the 6th of theta gives us the following. So I've got a cosine to the 6th of theta plus 3 cosine, looks like to the 4th of theta, plus 3 cosine squared of theta, plus 1 minus 1. So yeah, just factoring this out of the first 4 terms. So this seems pretty good because this factors very nicely. So let's note that. So we've got cosine to the 6th of theta. This right here will factor into, looks like cosine squared of theta plus 1 times itself, again times itself. Okay, so this factored nicely into this, and of course you can go ahead and check that. And so with that said, we can rewrite that, right? So just using exponent notation. So this is cosine squared of theta plus 1 quantity, looks like cubed. And then we've got this minus 1. Okay, so now let's do a little side investigation of this. Okay, so as a little side investigation, I've got sine of theta plus sine squared of theta is equal to 1. That tells me that sine of theta is equal to 1 minus sine squared of theta. But we know that 1 minus sine squared of theta is exactly cosine squared of theta by that classic Pythagorean identity. So I've got the following. And I'm feeling pretty good about that. So let's investigate. So what is cosine to the 6th? Well, if I cube both sides, it looks like sine cubed of theta is exactly cosine to the 6th of theta. So that seems pretty nice. So that means I can replace this with sine cubed of theta. And then what about this? Well, cosine squared of theta we said is exactly sine of theta. So let's go ahead and replace this with sine of theta. And of course that's cubed, right? So that's still cubed. So yeah, cosine squared of theta is exactly sine of theta. Notice I've got a product where both things are cubed. I can rewrite that as the first factor times the second factor. So cubed minus 1. So that's exactly a cubed times b cubed equals a times b quantity cubed. But if we distribute, maybe we'll notice something nice. So that gives me sine squared of theta plus sine of theta cubed. But from our assumption, we know that this sum is exactly 1, right? So we assume that sine of theta plus sine squared of theta is equal to 1. So from our assumption, that's exactly 1 cubed minus 1. And so it looks like this quantity is exactly 0 under this particular assumption. So yeah, quite a neat little problem.